Welcome YouTubers to another episode in my Grammar Hero series. In this video, I'm going to be working out practice problems from the Mathematics Knowledge section of the Armed Services Vocational Aptitude battery that is the ASVAB. Before I do that, however, I want to take a few minutes to discuss the ASVAB itself. First, I want to point out that the ASVAB is nowadays a computer adaptive test for which you'll have 154 minutes to complete 145 questions. Specifically, you'll be working on questions in 10 different subtests, including general science, arithmetic reasoning, word knowledge, paragraph comprehension, mathematics knowledge, and so on. In addition to receiving a score for each of these subtests, you're also going to receive what's called an AFQT score. Of course, AFQT stands for Armed Forces Qualification Test, and that's the score that says you're either qualified to join the military or you're not qualified to join the military. As you can see, that score is broken down in two different ways. It's broken down into ranges as well as corresponding categories. These ranges are given in percentiles. So, for example, if you scored a 50 in terms of your AFQT score, that means you've scored better than 50% of all test takers, and of course that would place you in the corresponding category 3A. As a rule of thumb, you want to strive to score somewhere between category 3 and category 1. That is, you want to score somewhere between 31 and 99. My advice to anyone who's studying for the ASVAB is to focus their efforts on 4 sections. The AFQT score is comprised of your performance on the arithmetic reasoning, the word knowledge, the paragraph comprehension, and the mathematics knowledge subtest. These 4 subtests, more specifically, are your scores on these 4 subtests, more specifically, are put in a formula, and that's how your AFQT score is calculated. So again, focus your efforts on these 4 sections. If you do well on these 4 sections, everything else should fall into place. So all that said, let's go ahead and get started with today's guided practice. One thing I want to point out before we get started is for the ASVAB, you're not given any aids such as a calculator or a formula sheet. Instead, you have to rely on your knowledge of how to do arithmetic as well as your knowledge of mathematical formulas to complete this section of the test. As you'll see in my video, I'm going to make an effort to work out everything in great detail. So if you're rusty with working with decimals or fractions, you should be able to catch up just by watching what I do. Similarly, I want to finally point out that the way you should use this video is as follows. As soon as I finish reading a problem, I would recommend that you pause your video, make an effort to work out the problem yourself, and then play the video to see if you and I came up with the same solution. More often than not, I'm going to come up with a solution the quickest and most efficient way possible. So again, it's always good to see how other people work out these problems. So that said, let's get started with number 1. A box contains 3 black, 4 red, and 5 white marbles. If one marble is to be picked at random, what is the probability it will be red? So we have a box here, and I like to sketch these out for whatever reason. It contains 3 black marbles, 5 white marbles, and 4 red. So in total, this box contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marbles. So the odds of picking any one of these marbles is going to be out of 12. The odds of picking a red marble is going to be 4 out of 12. Now at this point, I'd be looking at my answer choice to see if that's there. It's not. So we know we're going to have to reduce this. To reduce fractions, you ask yourself, what number could go into the numerator, that is 4, and the denominator, that is 12? In this case, it's going to be 4. So I'm going to divide top and bottom, numerator and denominator, by 4 to reduce it. 4 divided by 4, of course, is 1. 12 divided by 4 is 3. So we can see that answer choice is going to be C. So in other words, your odds of picking a red marble are 1/3. Okay? Alright, question 2 is not a good question. It's a little confusing the way they've worded it. So in light of that, I'm going to work it out, but I'm going to say that occasionally you do come across some practice problems that are just poorly worded and they're confusing. So if you find this problem confusing, just ignore it. Usually the ASVAB is worded very clearly. So let's go ahead and tackle it. In the figure above, the sides of triangle ABC are respectively parallel to the sides of triangle DEF. So ABC, DEF. If the complement of C is 40 degrees, then the complement of F is. So whenever they talk about complements and supplements, you need to know that complements refer to 90 degrees, whereas supplements refer to 180 degrees. So when they say the complement of C is 40 degrees, this is what they mean. Imagine that there was a right angle right here. Okay? The complement of C would be angle C, and it would be 40 degrees. That would make this 50 degrees. Together they would add to the right angle 90 degrees. Now, since these are parallel, we also know that this is going to be a straight line, and it's also going to be complementary, so we got to think of another right angle right here. Again, this you just have to understand is going to be 40 since these are parallel, and this is going to be 50. That's all the question's getting at. It's just worded very poorly in my opinion, so the answer would be C, of course. Alright, number 3 is a very good question, unlike number 2. And you will see something like this potentially on the ASVAB. For some reason this OneNote's giving me some issues here, so just bear with me. The sum, number 3, the sum of the measures of the angles of a hexagon is. So to find the sum of the interior angles of any shape, use this formula. 180 n minus 2. 180 times n minus 2, where n is the number of sides in the shape. So if you had a triangle, n would be 1, 2, 3. There are 3 sides in a triangle. If you had a square or rectangle, there was 1, 2, 3, 4 sides, so n would be 4. Hexagon, as you may recall, has 6 sides, so we simply plug in 6 for n and solve accordingly. So we're going to get 180. Again, a hexagon has 6 sides, minus 2, 180. 6 minus 2 is 4. So this becomes 180 times 4. Let's work that off to the side. 0 times 4 is 0. 4 times 8 is 32. Carry the 3. 4 times 1 is 4, plus 3 is 7. So we know 180 times 4 is 720. So we know the sum of the measures of the interior angles of a hexagon is 720 degrees. Again, just a formula that you should commit to memory. Not a hard one to remember either. Okay, let's move on to number 4. If a squared plus b squared equals a squared plus x squared, then b equals. Whenever I see a problem like this, I like to think of it like this. B equals, that is, you want b by itself. So in other words, we're going to have to rearrange these equations such that we get b by itself. So let's go ahead and do that. First, I'm going to write down the original equation. Okay, and since I want b by itself, the first thing I'm going to do is subtract a squared from this side. That's going to become 0. And what I do to one side, I have to do to the other. As you can see here, I have a squared here and a positive a squared here. This becomes a squared minus a squared, which is going to go to 0. So we're going to be left with b squared equals x squared. To get rid of this square, we're going to take the square root of both sides. This becomes b equals the square root of x squared is going to be plus or minus x. Okay, because regardless of what you plug into x squared in the square root, it's always going to be positive, so it doesn't matter if it's going to be negative or positive what you plug in. For example, if I were to plug in 2 for x squared, that would be 4. If I were to plug in negative 2 for x squared, that would also be 4. Okay, so this one is going to be a plus or minus x. Alright, number 5, of 6 plus x plus y equals 20, and x plus y equals k, then 20 minus k equals. Okay, so let's go ahead and write everything out. 6 plus x plus y equals 20, x plus y equals k, 20 minus k equals. So this, I don't know why I put 0 there. This is what we want to find out, and to do that we have to use these facts that are given to arrange the equation such that we get 20 minus k. If you took trigonometry, you would regard these as like identities. So what I can do right away is I know x plus y is equivalent to k, and as I can see right here, I have x plus y. I'm going to go ahead and replace that with k. So this is going to be 6 plus, again, x plus y equals k. So I can just plug k in right here. Equals 20. Okay, I'm going to subtract k from both sides. This goes away. We're left with 6 equals 20 minus k. Again, this is what we were after, 20 minus k. Do I have it? I do. It's equal to 6. Alright, the square root of 75. So in this case, we're looking for roots that are going to be even. So I know 75 is the same as 25 times 3. The square root of 25, of course, is 5. So this is going to, we can rewrite square root of 75 as square root of 25 times 3. Square root of 25, as I said, is 5. So we're left with the square root of 5 radical 3. And we can't simplify this any further. So that's going to be b. Alright, number 7. Square root of 960 is a number between what? So this is when it's helpful to be pretty good at estimating things. And I'm just going to do this because it's going to help you. 2 squared equals 4. 20 squared, therefore, equals 400. 3 squared equals 9. 30 squared equals 900. 4 squared equals 16. 40 squared equals 1600. I'm just going to do a few more. That way we can solve this problem logically, even though we can right now. 5 squared equals 25. 50 squared equals 2500. 6 squared equals 36. 60 squared equals 3600. Let's just do a couple more. 7 squared equals 49. 70 squared equals 4900. 8 squared equals 64. 80 squared equals 6400. 9 squared equals 81. 90 squared equals 8100. Okay, so you have to kind of know that these are equivalent. And if you do, this problem becomes very simple. The square root of 960 is basically asking you what times itself is going to get you 960. So we're going to be looking on at these numbers on the right. We can see 20 squared is 400, which is not big enough, and 30 squared is 900, which is not big enough. So this pair would not work because 960 is not between those two ranges. 30 squared is 900, which is close to 960, and 40 squared is 1600. So 960 falls within this range. So in other words, we know the square root of 960 is going to be somewhere between 30 and 40. Okay? If the measure of angle 2 is 80 degrees in the figure above, the measure of angle 4 is. So this is angle 2 right here. We know that's 80. These angles are corresponding, so we know that's going to be 80. We have alternating interior angles, so we know that's going to be 80. Okay? Again, this is primarily a geometry problem. So if you found it difficult, there's no other explanation I can give you other than that these are corresponding angles. I use the definition of corresponding angles to find this angle, and then I use the definition of alternating interior angles to realize that these two were equivalent. Okay, so this is a pure geometric problem. Alright, number 9, 10 to the 4th over 10. Instead of doing the big math on this problem, I'm just going to use my knowledge of exponents to make this problem a little bit easier. Let me say this. If you had a raised to the x power times a raised to the y power, the result would be a to the x plus y power. Okay? Similarly, if you had a to the x power divided by a to the y power, the result would be a to the x minus y. In other words, multiplication of exponents, as long as the bases are the same, causes you to add the exponents. Division of exponents, when the bases are the same, prompts you to subtract the exponents. Okay? In this case, we can see we have division of exponents with the bases the same. And I'm going to rewrite this as 10 to the 4th divided by 10 to the 1. Okay? So we can see we have this case right here. So that's going to prompt us to use this. So this is going to become 10 to the 4th minus 1, or just 10 to the 3rd. On the ASVAB, you will see questions regarding the laws of exponents. And for that reason, I'm probably going to make a video regarding exponents themselves pretty soon. If not, just Google for information about the laws of exponents. And there's only 3 cases you need to know, 2 of which I just mentioned right here. Alright, number 10. angle 1 and angle 2 form a linear pair and therefore are supplementary angles. If the measure of angle 1 equals 7x plus 6, and the measure of angle 2 equals 5x plus 18, then the measure of angle 2 equals. So again, earlier I mentioned the difference between complementary and supplementary angles. Complementary angles, I mentioned, add to 90 degrees, whereas supplementary angles add to 180 degrees. That is a straight line. So in this case, these two angles are going to add to 180 degrees, which is a straight line. We don't know how big they are yet, so we're going to do a sketch and just break them into two. Let's call this angle 2, and we're told that's 5x plus 18. Let's call this angle 1, and we know that's 7x minus 6. We do know, however, that when both of these angles are added together, that is angle 1 plus angle 2, they'll be 180 degrees. Instead of representing these with angles, we know we can represent them with the algebra, with the formulas given. So let's go ahead and replace those with 7x minus 6 plus 5x plus 18 equals 180 degrees. Let's combine some like terms before we do anything else, and I'm just going to drop off that degrees there. 7x plus 5x is 12x. 18 minus 6 is going to be 12x. And of course, it equals 180. Not x, just 12. There's no x associated with the 6 or the 18. So 12x plus 12 equals 180. Subtract 12 from both sides because we're solving for x in this case. That goes away. We're left with 12x equals 180 minus 12 is going to be 168. Divide both sides by 12, and I'm going to work that over here. This goes away, and we're left with x equals 168 divided by 12. Let's work that out to the side. 12 goes into 1, it doesn't. 12 goes into 16 one time without going over. 12 times 1, of course, is 12. 16 minus 12 is going to be 4. Bring down the 8. 12 goes into 48 4 times. 4 times 12, of course, is 48. So in this case, we know x is going to be 14. Now we want to know that the measure of angle 2. Well, we found x, so we can simply plug that in to our equation for angle 2, and we'll find out exactly what it is. So this is, in other words, going to become 5 times 14 plus 18. Let's work this out to the side. 14 times 5. 5 times 4 is 20. Carry the 2. 5 times 1 is 5 plus 2 is 7. So this becomes 70 plus 18. 70 plus 18, of course, is going to be 88. So we can see that this is going to be 88 degrees. Alright, number 11. If x equals y, find the value of 8 plus 5 times x minus y. Again, this is another identity problem where you have to use the fact that x equals y to find the answer. So we have x plus 5x minus y, and we're told x equals y. So let's work this out, and we'll see when it's appropriate to use this identity to simplify the problem. So I have x, or 8 plus, and I'm going to distribute this to x and y. So this is going to become 5x minus 5y. Now we're told x is equal to y. They're equivalent. So let's say x was 1. That would mean y equals 1. In this case, if I put 1 right here, this would become 5 minus 5, which would be 0. So given that x equals y, I could even write this, 5y minus 5y, which would be 0. So you can either plug in a whole number if it makes it easier to see, or just rewrite this as x is a y. But this is going to go away, and you're just going to be left with 8. Alright, number 12, look at the figures below. We have triangle R, triangle S, and triangle T. We're told that triangle R is 3 times triangle S. Triangle S is 3 times triangle T. If triangle S is equal to 1, what is the sum of the 3 triangles? So if S is 1, we know this is 3 times as great as 1. 3 times 1, of course, is 3. And we know that this is a third of S, so we know this is going to be 1/3. Okay, all we do is have to add those numbers together. 3 plus 1 is 4, plus 1/3 is 4 1/3. Again, we were told that this is 3 times as big as S, and S is 3 times as big as T. In other words, S is to find T, we'll take S and divide it by 3. That's how I got the 1/3. Okay. Number 13, how many different combinations of jackets and pants are possible from a wardrobe that contains 3 jackets and 5 pairs of pants? In this case, you just multiply 3 by 5 to get 15. This is a statistics problem. The very first problem I did today was in regard to statistics, namely probability. This is a permutation problem. If you need help with statistics and permutations, I would Google it. But this is one of those problems you just have to be able to see it. A lot of people, I remember in elementary school, would write this out. 1 jacket, 2 jacket, 3 jacket, 5 pairs of pants. So we got 1, 2, 3, 4, 5, and they would do something like this: 1, 1, 1, 2, or something like that to do it out by hand. Again, you can combine your 3 jackets with 5 different pairs of pants, so it's going to be 15 different combinations. Alright, 14. Divide 1.672 divided by 0.08. So we got 1.672. Going to divide that by 0.08. As far as dividing decimals goes, you cannot leave this number on the outside of the division bar as a fraction or as a decimal. So I'm going to move the decimal place twice here. And when I do that to this number, I have to do it here as well. So this becomes 8, a whole number, not a decimal, and 167.2. So again, you have to convert this outside decimal to a whole number to do these problems. Off the top of our head, we're going to be able to know that 5 times 20 is 100. So 8 times 20 is going to be 160. We know this is going to be very close to 20. In other words, just by estimating the answer, we know 2.9 is way too small. We know 0.29 is way too small. And we know 200. Well, what's 200 times 8? 1600. And we know that's way too big. So without doing any math, we can solve this problem, because we set up our problem such that it became very easy to see. That said, for practice, let's go ahead and work it out. 8 goes into 16 2 times. 2 times 8, of course, is 16. Subtract 16 minus 16 is 0. Got to bring down this 7 and bring down this 2. Now, when we move the decimal, the way you use it when you're doing long division is you just bring it right up in its same place. Okay? So we just brought down our 7 and 2. Does 8 go into 7? It doesn't. It's too small. Okay, so we know this is going to be a 0 here because it's too small. We have to actually go on to the 2. Does 8 go into 72? It does. 9 times 8, of course, is 72. Subtract, that's 0. Okay? If D equals RT, then R equals. So this is just prompting you to rearrange the equation. D equals R times T. We want to know what R equals, so we're going to rearrange the equation. I'm going to divide both sides by T to get rid of the T here. This cancels out, so I'm left with R equals D divided by T, or R equals D divided by T. Again, fractions are the same thing as division. D divided by T, D divided by T. And we can see that 15 is D divided by T. This is actually the distance formula. And if you take a look at my YouTube channel, you'll see that I have an entire video, which is about 35 minutes long, devoted to just working out problems involving this formula. So if you feel as if this is something you need practice with, go ahead and check out that video. It's pretty good. Alright, number 16, to find the radius of a circle whose circumference is 60 inches. Again, this is rearranging formulas. First, we need to know that there are two circumference formulas. The first of which is pi times diameter. Second of which is 2 pi times the radius. In this case, we're after the radius, so we know we're going to be working with this formula. We're told that the circumference is 60. So, again, the formula we're using is circumference equals 2 pi r. We're told the circumference is 60. So 60 equals 2 pi r. We want to know what the radius is, or r. So we're going to divide both sides by 2 pi. Divide this side by 2 pi. We're left with r equals 60 over 2 pi. And we can see that that's going to be b. Divide 60 by 2 pi. Alright, so which is not a prime number? So we have to look through all these numbers and try to figure out which one's prime. Just a rule of thumb, if something's divisible by 2, it's got to be even. And what's more, it's got to be just even. If something's divisible by 2, it's not prime. Prime numbers are only divisible by 1 and themselves. Okay? Similarly, if something's divisible by 3, we know it has to be odd. We don't care if something's divisible by 4, because if it's divisible by 2, it's also going to be divisible by 4, so we're not going to include that in our check. If something's divisible by 5, it's not prime, and 5 is usually a number that something's not divisible by 2 and 3 with. And the last one I usually check is 7. Okay? So if I'm checking prime numbers, I want to ask myself, is it divisible by 2? Is it divisible by 3? Is it divisible by 5? And is it divisible by 7? Okay? Again, I'm going to focus in on 87 because I know it's not even, so I know 2 doesn't go into it. What's more, the way you know if something's divisible by 5 is if it ends in a 0 or a 5. So for example, 1 or 10, 15, 20, 25, 30, 35. So if you were to ever see a number that ends in a 0 or a 5, you know right away it's divisible by 5. So I know this isn't divisible by 5. Let's do 87 divided by 3. 3 goes into 8. 2 times without going over 8 minus, or 2 times 3 is 6. 8 minus 6, of course, is 2. Drop down this 7. 3 goes into 27 9 times. 9 times 3, of course, is 27, so there's no remainder. So we can see right away 87 is divisible by 3, which means by definition it is not prime. Again, I just know from experience that this is prime, and this is prime, which is why I focused on 87 right away. Otherwise, I'd be going through my checks. I'd be saying, is it divisible by 2? It's not even, therefore it's not divisible by 2. Is it divisible by 5? Well, it doesn't end in a 0 or a 5, so it's not divisible by 5. And then I would actually do the division by 3. And then I would do the division by 7. Okay? So again, these are just my rules for checking a number of, seeing if a number is prime. There are many more of them, but these typically are the ones that will get you to the answer the quickest way possible. Just another, let me give you another example since this was kind of a bad question. Is this number prime or not? Okay, it's a big number. It's what? 100,005. Is it prime or not? Well, I just told you that if a number ended in 5 or 0, it's going to be divisible by 5. So without doing any math, I can say that this number is divisible by 5, therefore it's not prime. Okay? Alright, number 18. A is older than B. With the passage of time, the ratio remains unchanged, increases, decreases, and the difference in their ages varies. Well, we know the ages aren't going to change, so that's out of the question. So let's say A is 10 and B is 5. Let's say 10 years goes by. That would make A 20 and B 15. This ratio right here is 5 to 10. This ratio, which is the same as 1/2, this ratio is 15 to 20, which is the same as 3/4. Let's say 100 years goes by, and we can see that as more time goes by, these numbers get closer and closer to each other in terms of their ratios. So we know the ratio between them is going to be decreasing. Let's say 100 years goes by. That's going to be 110 to 105. And again, you can see that they just keep getting closer and closer. So this is going to be C. I don't like how this problem's worded personally. So if you didn't understand this explanation, don't worry about it. This is a poorly worded problem. Number 19, if you multiply x plus 3 by 2x plus 5, what will the coefficient of x be? So we're going to take x plus 3 and multiply it by 2x plus 5. To do this one, we're going to use the FOIL method. That is, I'm going to take this x, multiply it here, multiply it here. I'm going to take this 3, multiply it here, and multiply it here. So x plus 2x becomes x times 2x becomes 2x squared. X times 5 is just 5x. 3 times 2x is 6x. 3 times 5 is 15. Let's combine like terms. 2x squared plus 5x plus 6x is 11x plus 15. We're asked what the coefficient of x will be. This is x squared, so we don't want this coefficient. This has no coefficient of x. Here's the x. Coefficient is 11. Alright, so in the previous problem we used the FOIL method to solve it. So in this case we're going to do the same thing. That is, I'm going to take this x, multiply it here and here, take this 3, multiply it here and here. So let's do the x first. Again, we're going to multiply it there and there. X times x is x squared. X times 2 is 2x. 3 times x is 3x. 3 times 2 is 6. Combine like terms. X squared, 3x plus 2x is 5x plus 6. So this is x squared plus 5x plus 6, which is right there. Alright, number 21. The perimeter of a rectangle is 90 degrees. So let's draw a rectangle real quick. One side of the rectangle is twice the length of the other. What is the length of the longer side? So, perimeter of a square or rectangle is side plus side plus side plus side. In this case, we're told one side is twice as long as the other. So this would be 2s and this would be s. In other words, this is 2 times the length of side s. So this is going to be 2s and this is going to be s because, again, these sides correspond and these sides correspond. Now the new perimeter is going to be s plus 2s plus 2s. Again, just adding up all the sides, albeit with the new conditions I put in. Perimeter is going to be s plus s is 2s, plus 2s is 4s, plus 2s is 6s. We're told the perimeter is 90, so 90 equals 6s. Divide both sides by 6. This crosses out. We're left with s equals 90 over 6. Let's work this out to the side. 6 goes into 9 one time. 6 times 1, of course, is 6. Subtract. 9 minus 6 is 3. Bring down this 0. 6 goes into 30 5 times. 5 times 6 is 30. Subtract. This is 0. So we know s is going to be 15. That means this side's 15. This side's 15. This is 2s. If s is 15, we know this is 30. And this is 30. So in this case, we know the longer side is going to be 30. 22, the area of the figure above can be determined by the formula. Well, this is a triangle. The area of all triangles is 1/2 base times height. So in this case, it's going to be 1/2 base times height. And again, you can see this is our base. We have our height here. So the formula works. 23 of psychological studies of college students show K% to be emotionally unstable. The number of college students not emotionally unstable per 100 college students is. So if a study found 5% are unstable, that means 100 minus 5 would get us the number or percent that are stable, are 95%. So in this case, we know this is k, so this would be 100 minus k. So it's going to be 100 minus k. Not a very difficult problem there. A cogwheel having 8 cogs plays into another cogwheel having 24 cogs. When the small wheel has made 42 revolutions, how many has the larger wheel made? So these are cogwheels. They look like this. They're basically gears. And in this case, we have one small cogwheel, one big cogwheel with. This one has 8 cogs and this one has 24 cogs. So in other words, by the time this one makes 3 revolutions, this one will have made 1 revolution. Again, 24 divided by 8 is 3. So it takes this one 3 times to go around to spin this one once. So if this one goes 42, we know that the big one's going to go 42 divided by 3 times around. 3 goes into 4 one time without going over. 3 times 1, of course, is 3. Subtract 4 minus 3 is 1. Bring down this 2. 3 goes into 12 4 times without going over. 3 times 4, of course, is 12. Subtract, no remainder. So if the little one goes 42 revolutions, we know the big one's only going to go 14 revolutions. 25, a quadrilateral is only a square if. So we know squares, in squares, all the sides are equal. We know they have interior angles of 90 degrees. So if it has 4 right angles, well, that's true, but what about the sides? All the sides are equal, so that's only partially true. It has at least one pair of parallel sides. Well, these sides are parallel, as are these sides, so it has 2 pairs of parallel sides. 25, it has 4 right angles and 4 congruent sides. Well, that's the first thing I said after I drew the picture of the square. Both of the pairs of opposite sides are parallel. That's true, albeit impartial. We need to know about the angles, and so for that reason that's not correct. So the answer is 25C. Okay, so that's all I have for you in this video. As you may have noticed, this video kind of focused more on algebra than anything else. So if you found it helpful, feel free to leave some positive feedback in the comment section below or thumbs the video up. But on that note, I'm going to go ahead and cut you loose.
Konnichiwa.